today, hang on, let me get my focus back here. Today, for today's lecture, we're extremely lucky because we've got a great gift before the mid-semester break. We've got my colleague, Penny Kybers, who's going to give a guest lecture. And this is one for everyone. The last guest lecture was just for the 1140 students. This guest lecture is for everyone in the class. And I think you're going to find this really interesting. There are lots of topics here which I think will appeal to you. And as usual, use the Teams chat to write questions. I'll be there instead of Leo, monitoring the chat, and I will try and capture your questions and raise them with Penny as we go along. Now, without further ado, I will try and flick to Zoom, and if all is good, we'll hang on one second. I'll flick to Zoom here, and if all is good, you will be seeing Penny on Zoom in a nanosecond. Here we go. Yep, there we are. There's Penny. So everyone, welcome to Penny Kybers, my colleague at ANU, and she's going to give out today's guest lecture. So thank you, Penny. Over to you.
Thanks a lot. I'll just try to share up my slides now. Okay, can you see that okay?
Yep, I can see it perfectly. Let's just make sure it's coming up on the stream, which is a little delay. And 1, 2, 3, there it is. Yep, it's up on the stream, and I've got a thumbs up from Leo on the audio too, so it's all good. So thank you, Penny. I'll hand over to you now.
Great, thanks so much. Thanks for inviting me to come in today. So as Steve said, my name's Penny Kybers. I'm a Games and HCI lecturer in the School of Computing. I'm going to talk a bit generally about myself and my background, but also talk a bit in depth around one particular project or line of projects related to human AI teaming in video games. So hopefully it's something that you might find a bit interesting. Okay, so yeah, I'm just going to talk a bit about myself. What have I done? What's the research that I'm doing at the moment, and what I'm going to work on for the next little while as well. So please do feel free to just interrupt me as I go through and ask questions. Happy to answer any questions around the games industry or what sort of jobs there are, what it's like working in the video games industry, or anything else that kind of grabs your attention as we go through. So what do I do? This is a bit of a joke that I prepared. What my students think I do, what my parents think I do. It's a bit laggy. What my boss thinks I do, what I wish I did, what I like to think I do, which is kind of a bit more of a scientific version of the gaming perhaps. And what I actually do is, I think, a lot of answering emails and admin, which I'm sure Steve feels as well. Oh, sorry, my Google slides are a bit hectic. All right, what have I done? So this is a bit of a story that I like to tell of my interesting career path in a picture format. So just imagine yourself winding a way through the campaign of some kind of video game. So I did my PhD and also my undergraduate, which was in information technology at the University of Queensland. Finished my PhD back in 2005, which seems like a very long time ago now. And I did my PhD on an emergent approach to game design and development. And then I realized that I didn't want to be an academic, so I promptly went off to work in industry for a few years, and I worked in Brisbane at Creative Assembly, which was bought by Sega. And then I came down to Canberra and I worked at Irrational Games, which was bought by 2K Games. So they were both kind of nice independent developers that were bought by large multinational publishers, which had a bit of an interesting effect on the working culture. And then I spent a really brief amount of time working as an independent game developer before I went to work at QUT in Brisbane. So I went there to do some games research and games teaching for a while. And then after I had my 2 kids, you can see these little bunny rabbits here, I went back to work as an independent game developer. And so it was kind of nice, a bit more relaxed, as I had small kids, and I sort of worked around their schedules to create games. My husband and I run a games company called Iron Helmet Games, and they're what we call social strategy games. And so they're kind of a bit like board games online, but also a little bit of a social experiment. One of the games, Neptune's Pride, has been referred to as a space bastard simulator. It's just, people get really into it. You play around the clock. It's like a real-time continuous game that moves slowly, and so people get really paranoid. It's very competitive, so it's kind of a bit of an interesting experience. Don't try it unless you cannot take it too seriously, perhaps. And then an interesting opportunity came up. This toadstool here is the Australian Senate. So I actually worked in the Australian Senate as a policy advisor for about 18 months. I worked on digital and communications policy, things like privacy and encryption, and video games was surprisingly something that came up as well. I instigated a Senate inquiry into loot boxes by a motion that I wrote. So I had a bit of an interesting time working there, and some cool things that I got to have a look at. And then I came to work at ANU at the end of 2018, and here I am, to be continued. So some of the games that I've worked on, so as I mentioned, I worked for some larger AAA publishers. So this is what you might equate to maybe to like a blockbuster sort of thing. So these are large budget games up to maybe $50 or $100 million. So they tend to have very high production values. They have maybe 100 people or more working on them. So games like Medieval or the Total War series of games. I worked on an XCOM game. I worked on some of the BioShock games. And these other games you hear on the right are actually some of our independent games. So you can see they've got a bit more of a board game look and feel to them. Certainly not $50 or $100 million budgets, I can tell you. We did get a little bit of funding from Screen Australia, which was nice, and Screen ACT, but a lot more modest. So mostly my husband and I, and we also contracted mostly some artists and animators. When you're an independent developer, you tend to do everything, but an artist, I am not. So I didn't do any of that. So some of these big games, a lot of players. My rough estimate is over 10 million players and over $250 million in revenue. But it's really hard to tell because the industry tends to keep a tight hold on the figures. So some of them got nominated for some pretty big awards, things like the British BAFTAs, British Academy of Film and Television Awards, and some magazine covers, which is kind of a big deal if you're a game developer. Magazines, I guess, are not really a thing in the same way that have covers anymore, but they did pretty well in some of the games. So some of the highlights of my research. So my research, which I'll talk about in a minute, kind of spans some different kind of perspectives. But during my PhD, I was working on this emergent games engine technology, is what I called it. So it was this cellular automata-based system that aimed to model physical phenomena in a kind of simplified way that would give rise to emergent and diverse gameplay via the use of complex systems. And so this book here, Emergence in Games, is a book that I published after I finished my thesis, sort of based on my thesis, but in more of a kind of broad appeal textbook kind of way, because your thesis was pretty focused on the development. So I developed this game flow model, which was a model of enjoyment in games. And I developed this because I needed it to evaluate the system that I'd made. And the funny thing was that after I left academia and went into industry, other people started using it, and a lot of people started using it. And it became kind of the model that everybody used to be able to measure or evaluate or design things to be enjoyable in video games. And I think the thing that made it useful was that it was a tool that I needed that didn't exist, and it was just, it happened to be a lot of other people were in that situation as well. So that was an interesting kind of outcome there for me, and it's been applied. So last year I wrote this review of how it had been applied over the last 15 years, and I found out that it had been applied to the design and or evaluation of over 200 game or applications. So not just games, it's had a lot of pickup in game-like experiences, or even education or health settings where people are trying to imbue aspects of enjoyment or motivation. So you're probably not familiar, but there's this concept of flow developed by Csikszentmihalyi, who is a pretty famous psychologist, and it's about understanding optimal experience. So what makes something engaging and enjoyable and worthwhile doing. So really deep kind of satisfaction. And he did a lot of research on why people, particularly people kind of at the top of their game, elite athletes, elite chess players, why do they do what they do? And so he found these common elements and built them into this model that he called flow. And so game flow is basically based on this, but it was based on the literature at the time, and I constructed it into these elements. So concentration, challenge, skills, control, clear goals, feedback, immersion, and social interaction. And these elements are kind of really common across anything that people feel engaged or immersed in, and even education or reading. You find that you want it to match your skills, you want it to push you a bit further, you want it to challenge you, and you want to feel like you've got some sense of mastery and control, and that's where the experience really kind of takes hold for you. Just quickly, another thing to mention is I also, when I was at QUT, I wrote this paper on active versus passive screen time, and it was a bit of a lobbying for why games are good. And at the time, there was a lot of sentiment or commentary around games being bad, games making people violent, games making people depressed. But we actually analysed a bunch of data of children's screen time habits, and also we reviewed the body of literature at the time, which showed that, actually, if you're actively playing video games as opposed to passively consuming TV, then it's actually going to give rise to a lot of benefits in terms of, cognitive benefits, as well as dexterity and motivation, and just all those kind of good things that you get from, challenging yourself and pushing yourself a bit further. So I feel like I missed a slide somewhere. Oh, here we go. So I kind of covered this a bit, but so I like to say I use video games to understand humans, machines, and the world around us. And so I work at this intersection roughly of these different three areas. So games, virtual environments, and extended reality, artificial intelligence and machine learning, and human-computer interaction. And so the main thing for me is that it's got that intersection point with games and virtual environments. But for me at the moment, the really sweet spot is this one in the middle of these three areas is what I find really interesting. So it's part the Google slides and part my Apple mouse that just doesn't work right. So what are we doing? So I want to give you just a bit of in-depth on one particular project, and this is just for your interests. So I think Steve was worried you might think it was on the test or something, but it's not. So just, So just if it's something that you're interested in, please feel free to ask me about it as well. So we've got this paper that's been accepted and just kind of being revised for publication at the moment. But in general, the line of projects is around human AI teaming in video games. So I called it hybrid human AI collaboration in complex real-time video games. So it's about really looking at ways that we can combine human intelligence or human capability with machine capability. I was interested in, I put this project up actually to defense, and I'll talk a little bit about that. But what grabbed me at the time when I proposed this last year was that a lot of research in games AI tries to make human superior AI. So it's about replacing the human. It's about beating the human. Whereas I think there's really a lot of potential to use AI to actually pick up where the human is weak, or to compensate, or to support. So thinking about, if we combine humans and AI, how can we make something that's better than both? So, the whole is more than the sum of the parts, sort of thing. So, humans are good at some things and AI are good at other things. And how can we best combine those to produce, the best team that we can? So human AI teaming offers significant opportunities for improving overall performance, but it's also extremely, challenging. There's a lot of challenges, and we found ourselves kind of going down a rabbit hole in terms of just understanding, defining, mapping the problem space. So I'm going to present the way we went about trying to understand this, because it was, by nature of the problem itself, it had a bit of a unique approach to it. So our research aims to investigate human AI teaming for defense scenarios. And my interests are actually a lot broader than defense, but the one thing that defense is going for it is it's prepared to pay me to do this research. But I'm hoping that it can have much broader applications than defense. So last year, we conducted phase 1 of this research. We conducted a comprehensive literature review on human AI teaming. We carried out a survey of potential game environments that we could use to carry out this work, to use as test beds. And we developed some scenario ideas with the defense science and technology. So we conducted what we called, in the end, an agile literature review. So I don't know if you're familiar at all with the agile approach, but it's something you'll definitely learn about as you go through your degree. So it's a very popular approach to project management in games, but also in technology projects more broadly. So we started with kind of a traditional literature review, where you go and you search the papers that are available in the field. And what we quickly realized was that it was so expansive. It just touched on so many different things. It was really hard to know where to start and where to end. And so what we then did is we went and we started generating user stories. And so we generated these user stories from the literature, and also by brainstorming with each other, and also by discussing with our stakeholders to find out their requirements and how they were going to use this technology. And we developed up this base of user stories. I'm going to give you a snapshot of it on the next slide. But this allowed us to structure the research into this backbone, so into these 5 core areas: bidirectional situational awareness, human AI interaction, distributed decision-making, and human AI operations, and transferability, which I'll talk about a little bit in a minute. And so within those, we kind of expanded it out into these different subcategories. And then we went back with this structure and we searched the literature again. And that's where we got our final body of work that we used for our literature review. And in doing this, we kind of also put forward this interesting approach of conducting an agile literature review and using the agile approach for research project management, which hasn't been done very much before. I need a different mouse, I think. So this is the user story map that I mentioned, and this kind of shows you all of the different stories that we made from based on the literature, discussions, and brainstorming. One of the interesting things was that we went down this really kind of unique path where we started writing these user stories based on the AI teammate and what it wanted. And I thought there would be a whole interesting paper just sort of talking about from the AI's perspective, what it expected to how it's expected to work with the human and what expected to get out of the situation. But it was kind of this weird path of personification, but useful all the same. So I won't go into a lot of detail on all of those different elements, but I will kind of step through them. But I wanted to talk about the core research proposition. So the thing that held together kind of all of the different things that we investigated was this idea of trust and transferability. It was so central, and it touched on all the different things in the backbone. And also the idea that trust and transparency were bi-directional. So it's about the humans being comfortable collaborating with the AI teammates. So thinking about expectations, information, assumptions, but then, so not necessarily the AI is comfortable, but the AI teammates are successfully collaborating with the humans. And so it needs to have, I don't want to say self-awareness, but it needs to have some self-assessment and be able to assess itself, its own state, the human and the team. So even asking questions like, is this the human that I expect to be operating with me? Is my human compromised? They might be injured. They might be compromised security-wise. There's a lot of questions to ask there. And then, the fundamental goal is superior decision-making in difficult conditions. So the second thing, transferability, is really comes out of the use of video games in this context. So it's really important to us that we're able to show that we can take this research, we can conduct it in game environments, and we can make it applicable and transferable to the real world. And so this transferability piece is really about us developing and delivering a process that we've sort of demonstrated works and that kind of validates this research idea. And I'll talk about why we're using games in a minute as well, not just because I'm a games researcher. So I'll skip through some of these ideas fairly quickly, but so some examples. Bidirectional situational awareness includes sensing, communication, and schema. So, fundamental to any decisions that you're making as a human or as an AI, so this is pretty central to agent development as well, you need to be able to sense the information in your environment. So this is about how the human or the machine or both take in and process the information in the environment. Communication, so they need to communicate that information with each other. And schema is about who's responsible for which information and which communication. Intelligent decision superiority, so shared understanding. And this is a big issue, even just with human teams without the AI. So is getting that shared understanding of the space. Going back to the trust and transparency piece, which is really central to all of this work. Looking at, you can actually build trust. If trust is broken, you can rebuild trust, being able to adapt and calibrate to different levels of trust. And trusting machines is a pretty fundamental issue to a lot of AI research. Transparency, particularly if you're using something like machine learning, you need to have some kind of transparency in order to engender trust in how those decisions are made. Disuse, so under-reliance, and misuse, over-reliance on the autonomous teammates. So, there could be such a thing as too much trust. Operational efficiency, so going back to that fundamental question of capability, what can machines do and what can humans do? What should each of them do? And what are the costs of them doing those things? So, machines can process a lot of information very quickly, whereas, it can be very time consuming and costly and not necessarily a good use of resources for the humans to do that work. Whereas the humans can make sort of more strategic, high-level decisions faster, particularly if they've got a lot of experience that can be difficult for a machine to make decisions around with that level of nuance. This is a big thing, particularly in defense, who can do what with what authority. So, it's kind of necessary to understand exactly those boundaries and where they lie, particularly in a military context. Evaluating, so being able to have metrics and to be able to say, did that work? Are we winning? What's the result? What's the progress? So having very solid metrics to be able to evaluate the process and the progress and correcting. So this is something where machine learning and AI has a lot left to be desired in terms of, if something went wrong, do I know that it went wrong? What can I do to minimize the damage or reverse any issues that were made? So this is a diagram that one of my colleagues made, which I think shows a bit into the inside of her brain, but it's what this is the kind of the agile approach is incrementally working our way out through each of these dimensions, adding on layers of complexity and testing at each stage that it's actually working and it does what we think it does before we add on further layers of complexity. And this is our paper that we wrote, and the result of all of this work, this agile literature reviewing that we did, was this proposed research framework. So how people can go about researching in a highly processed or highly ordered way the development of human AI teaming. And the transferability piece is really when you're doing it in an environment that's not the real environment. So that's terrible. Sorry. So why video games? So video games are really, so one of the things I said at the start was that I use video games to understand humans, machines, and the world around us. And so they're a really good environment for testing and for modeling and for trying things out. They're a safe environment. Obviously, there are some issues about it's not the real world, but in a lot of ways, it can be quite analogous to the real world. So they can be appropriate and effective for simulating and evaluating tactical warfighting scenarios or other sorts of physical or decision-making scenarios and environments. So getting a ready-made game, ideally a complete game, gives you kind of a complex real-time environment. So I'll talk about in a minute, but a game like StarCraft, a game like a real-time strategy game, you've got a lot of incomplete information, you've got a lot of competing tasks and priorities, you've got built into the game what makes it cognitively challenging for a human or an AI to undertake. And so if you approach an environment like this, you don't have to do all the hard work of implementing those tasks and those challenges and balancing it. It's kind of already there. Games are being increasingly used for defense research in Australia, US, and the UK, as well as a lot of other sorts of things as well. And if we think not just games, but game environments, we start to think about things like virtual reality and augmented reality as well. So one of the key things is that you're in this kind of safe, controlled, reproducible, and highly measurable environment. So this is a nice, safe, ready-made test bed for doing a lot of AI research. And this is why I like these environments for testing out new AI or machine learning algorithms as well. You can isolate different components or relationships and sort of target them, and then you can build up the increasingly complex scenarios. Competitive environments, measurable outcomes. So we know that a game like StarCraft is challenging for a human to play, it's challenging for a machine to play, and they've put a lot of work into balancing a game that is competitive multiplayer game to make sure that it's a level playing field. So for human to human, AI to AI, or human to AI. And Blizzard increasingly continuously releases updates to make sure that any exploits are kind of minimized, and that it really is kind of a level playing field for anyone to compete within. So we went through this process of, we developed these heuristics, or these criteria: complexity, tooling, customization, suitability, and community, for evaluating what environment we wanted to conduct this research in. And so this is the scoring that we came up with. StarCraft 2 was the clear winner, but it was particularly within, including elements like complexity. So we wanted a game that already had that gameplay complexity, so we didn't have to build a game from scratch. It's got good tooling, it's highly customizable, it was suitable to the scenarios that we had come up with, and it's got a really strong research and user base as well. So you can have a look at some of the other environments: Minecraft, Unity, Doom, some of the different things. A lot of RTS games in particular we were looking at. Cool. So yeah, so as I said, StarCraft had the best overall performance. It was challenging for both humans and AI, well-developed open source APIs, allows for a high degree of customization of type and difficulty of challenges, suited to our requirements, and active research and player communities. So the other environment, which is worth mentioning, and it's something that we're considering using for a different project, is Unity, or you could also think about Unreal as well. So this is just kind of more of your standard games development engine. And so it doesn't have the complexity in that it's not a ready-made game, but it has full flexibility. So this is the best flexibility. You could make if you use StarCraft, you're playing in an alien world with aliens as your units, and so it does require some stretch of the imagination. If you want a realistic environment with humans and buildings and tanks or whatever you want to create, then something like Unity allows you to create whatever environment it is in a realistic kind of way, if that's what you want. Or alternatively, you can strip out all the details and just have like a box world where everything is abstract, which is kind of interesting and useful in some scenarios as well. It's well documented. It's really standard tool now. It's sophisticated, it can do a lot of things, and they're continually updating it. So I'm going to just give you an idea of a couple of the scenarios we came up with these 4 scenarios: asymmetric swarming, layered missile defense, land-based tactics, and tactical picture compilation. So one of the ones that I found quite interesting, my background was in, emergence and complex systems, was this idea of asymmetric swarming. So having like one large entity that's trying to be overwhelmed or trying to be defeated by a swarm of low-cost weak units. And you could imagine the swarm to be some kind of drone or low-cost robot, versus this might be some kind of giant, tank or something. So I've got a video that one of our students made last year, just to kind of capture the imagination in terms of what could be done in StarCraft around swarming. So StarCraft has inbuilt swarm mechanics, which makes it useful. So some of the little units like Zerglings and things already have swarm movement, and so it kind of lends itself to this idea of swarming. I hope that video is working okay. So what you can see there is the student had set up some kind of commands that you would type in, so attack or A, and these were mapped to kind of some strategy that was layered over the swarm mechanics. And so you can imagine yourself maybe using like some kind of playbook to give these high level orders, whereas the formations and how those orders interact with the swarm are not something that you need to control at a low level. So you'll just say, I want to attack, or I want to flank, or I want to do this kind of maneuver. And maybe you're kind of thinking about even some sports plays that you might put into action and how that would interact with the swarm. And so as a human, you're just giving those high level strategic orders, and then the AI takes over the low level implementation of that. I'm trying to go to the next slide. Okay. Oh, keys. I should use keys. I know, now we're done it. Okay. All right. So I'll just quickly talk about the other scenario, which was about layered missile defense. So imagine that you're looking to defend against incoming missiles, and you kind of have a layered set of responses that you could take depending on what stage of the threat you're at. So, you've found a silo, it's been launched from the silo, or it's incoming, and then you've got to start making decisions about prioritizing, the survival of different assets and how you can intercept as you get down to the level. Cool. So what's next? So Defence have funded a PhD scholarship, and I've got a student who's hopefully starting later this year or early next year, and they're going to be researching this sort of project, but more from a Defence call it mixed reality, but I would call it extended reality. So this includes all of the different realities that are not reality. So this would include augmented reality, virtual reality, mixed reality, different ways of combining the physical world with the virtual world and overlaying it at different levels. So if you're talking about virtual reality, you're kind of entirely in the virtual space, except your movement and yourself is in the physical space, obviously. Augmented reality is kind of the other end of that. So you're mostly operating in the physical world, but you're laying over information from the digital world. So this project is about thinking about human-machine teaming and decision-making as the domain, but saying what are the best technologies that we can use to facilitate this. So even though I like to do research in these extended realities, I always remind myself that if all you have is a hammer, everything looks like a nail. So you shouldn't go in technology first. Like, it's important to understand the problem that you're trying to solve and to pick the best technology that you can to actually support that in a meaningful way. So this project is it's kind of more of a human-centered investigation of what can be supported in those different technologies. So moving a bit broadly beyond that particular project, I was just going to overview. I've got 6 PhD students at the moment, and I've got an additional one that I'm co-supervising. So I've kind of got this spectrum of different projects that include some that are really just machine learning focused, through to some that are a combination, then through to some that are really that human-centered side of things focused. So, the first 2 projects are kind of good comparison there. The first one is a reinforcement learning project, and the second one is about understanding how video games can be leveraged to persuade people around a particular topic. So perhaps going back to that idea of game flow and how it hooks into, different motivational affordances and different aspects of enjoyment. How can we use that to persuade people that something like climate change is real important and needs attention? And then I've got some other projects that are kind of in between as well. So this is just some of the the coursework projects that I've been supervising. A lot around AI and games. So reinforcement learning is something that's tested quite a lot in video games. Other sorts of machine learning, so generative adversarial networks, various sorts of deep learning and machine learning. I think I'm really interested in that kind of sits under this human AI teaming is this understanding how to model players, how to measure players, how to adjust games to suit players. It's kind of more of like a subversive kind of AI. So it's just kind of understanding what's happening with the player and just making small changes so that the game and the environment is better suited or better customized towards them. I'm really interested in, so I think when people think about human AI teaming, you probably, imagine that you're working with this robot, but the way I initially pitched it to defense was that all games have a layer of some level of automation. And so we can think about if the goal is to have overall better team performance, of just shifting the bar of that automation to try and increase the overall performance. And that doesn't have to be in a really, here is your AI teammate, now talk to it. It can be in kind of a really hidden kind of way, in the way that, you have automation sort of creeping up in cars and other devices. Cool. So this is just a summary of some of the other things that I do. So at the moment, I'm teaching the human-computer interaction course. I run the internship program. I run the individual projects. I was previously working with Tech Launcher. So as you go through, these are some of the places that you might find me teaching. Yeah, but I think that's probably it. Really happy to take any questions, comments, opinions, whatever is going.
Great, thanks so much. Can you hear me okay, Penny? Oh. There we go. Sorry, I was muted. Thanks so much, Penny. That's fantastic. I've got a couple of questions in the chat. The first one, so there's a couple of, there are three related sort of reasonably deep intertwined ones, but I'll first ask a very high level one that someone else posted. Wang asks, is HCI mainly applied to the game industry? So I wonder if you could respond to Wang's question.
Yeah, so do you mean as opposed to how it's applied to other industries?
I think he's, my reading of the question is that he's asking about where does HCI get applied broadly? Is it mostly in the game industry, or are there other applications of HCI? I think that's the question Wang is asking.
Yeah, so I mean, HCI gets applied very broadly. So it's really, it used to be quite specifically about human-computer interaction, where a computer was just this thing that you specifically went to interact with when you were doing your work. So now it's much broader than that, because computers are, or machine intelligence, or however you want to spin it, is basically embedded in so many things around you. So it's certainly not just games, and it's certainly not just computers. It might be, if you've got a smart toaster, or, how you interact with your car. It's any way that you're interacting with something that's got some kind of computation embedded with it. In a way, games were even kind of a latecomer to the whole HCI phenomenon, which is why when I was doing my PhD, I had to develop this game flow model, because people weren't really researching HCI and games, even though inherently you're making this virtual experience for the purposes of enhancing someone's player experience. But no, HCI is big.
Great, thanks so much for that. Now, there's a little thread here of questions, and I'll just read them all out for you first, and then I'll get you to respond if you wouldn't mind. So, Adnan asks, how would you balance the AI and the human when it comes to things like precision and brute skill in games? E.g., in a shooter game, the AI would be able to aim perfectly, so the game should, in some sense, be much less challenging for the AI. Oops, screensaver cut in at the wrong moment. Would you choose your game so as to minimize the extent to which these factors affect performance and maximize reliance on strategy and cooperation? That's the first part, but there's a follow-on. So I'll just read these out. Michael says, Adnan, one idea is to handicap the skill of the machine opponent so that the physical reaction time speeds, APM, etc., are on par with the human player, so it comes down to strategy and decision making. I believe that this is what DeepMind did when it was created the AI for SC2. And then someone has a follow-on question in the same thread. It says, relating to Adnan's question, how close to a real human player should an AI emulate their behaviors, etc., and so on in games? So there's a whole bunch of things there about the relationship between the AI player and the human player. I can repeat any of that if you'd like. But
no, I think it's good. I think it's good. So yeah, I think the interesting thing when you're designing an AI for the purposes of enjoyment in a game is that you don't want it to be superhuman unless that's its role in the game. So if you're developing a competitor for the player in something like a first-person shooter game, usually you do have to impair the AI in some way, because if you let it shoot at the target and it's got perfect knowledge of the target, then it's going to do it extremely quickly and extremely accurately. So it's no fun for the human player. You have to create that level playing field. So a lot of the time, when you're making a game for enjoyment, you really need to think about the role of the AI. So what is its purpose? What is its purpose in relation to the experience you're trying to create for the player? So definitely it's a lot about keeping it in its box and having it try to come down to the human's level in a lot of ways. And if it's really about those physical skills, humans are kind of slow and they're not very accurate. So you are kind of bringing the AI down. There was an interesting thing about AlphaStar in there as well. So DeepMind's StarCraft 2. So the thing about the APM, so the actions per minute, is that humans actually can do a lot of APM. But a lot of their clicks are wasted. They're pointless. They're missing, they're scanning around, whereas the AI has that kind of precision and perfection again. So AlphaStar can actually do the same tasks as a human in less clicks just because of that, barrier that the human has in physically pressing the mouse button to interact with the computer. So that's kind of an interesting angle there as well. I can't remember what the last question was now. I don't know if I answered it.
Yeah, the last one was, how close to a real human player should an AI emulate their behaviors, decisions, and so forth, which I think you might have already answered.
Yeah. I'll just add one thing there. So one of my favorite things to say is that if you're designing a strategy game, if you're designing a strategy AI to compete against a player, you've got to remember its job is to put up a good fight and die admirably. Like, your job as an AI developer is not to make it beat human into a pulp.
All right, I've got a couple more. I've got quite a few more questions here. Let's. We've got 9 minutes left, if that's okay with you, Penny.
Yep.
So I've got one here from Zhang Han, and they ask, is it possible for a machine to replace people in game planning and management for maintaining game balance?
Yeah, I mean, I'm not 100% sure what you're referring to, but I was just, something that you might be referring to is that you can use machines to help in the designing of games in some way. So I've had the job of having to balance, some very complex strategy games, and there is a lot of numbers, there's a lot of equations, there's a lot of parts of the game to sort of factor in. And so increasingly people are developing AI or machine learning algorithms that can help with that task of the balancing of the game, or even having an AI that can go through and more, systematically test out all the different parts of the game. So I'm not sure if that's what you mean though.
Well, if Zhang Han has a follow-up question, they can post it in the chat. Thank you, Penny. So Hua asks, what would you suggest us to do in order to have access to existing games to run an experiment in a cost-effective way?
Yeah, so StarCraft 2 is really good because Blizzard partnered with DeepMind to develop the StarCraft 2 learning environment, and so they've got APIs. You can develop your models in Python, and you can you can test them out using existing replays, or they've got all the kind of the environment set up for you to be able to do that. It's free to access, which is great. So that's probably one of the better ways. You can also, things like Unity have a lot of flexibility in terms of being able to access it for free and try out different algorithms. And there's a lot of work going on already from different researchers, so it's pretty easy to get access to, say, some existing models that you can just plug in and try out as well.
Great, thank you. There is a follow-on question from them, from Hua, who says, are there any ethical concerns that need to be addressed when running experiments that aim to combine the power capacity of AI and a human?
Yeah, I mean, I think there are always ethical concerns in terms of this kind of research, or any kind of research, and obviously it's something that we think about, particularly because we're carrying out research for defense. One of the things that perhaps makes me a little bit more comfortable is that we're trying out things. None of our work is at a secret level, and we're working with publicly available games and tools. We'll make our work publicly available, and then you've got that extra element of transparency and scrutiny from the rest of the community as well. But I think depending on how you're using it, particularly if you're involving people in your experiments, and what your goals are, there's a lot of different ethical considerations to think about, really. There's really a whole growing field, and cybernetics at ANU has a lot of focus around kind of those socio-technical and ethical considerations of this kind of work.
Great, thank you, Penny. Another question here from Karthik. Karthik asks, I think good AI examples of AI teammates are Final Fantasy series or the Monster Hunter series. They accompany or support the player actions and base their decisions on how players decide to approach the game. Well, that's more a comment than a question, but that was a comment from Karthik.
Thanks.
All right. And the next one is from Chibin, and they ask, what about cooperation among AIs? That could impact the game difficulty greatly.
Yeah, so I mean, one of the things that we're interested in thinking about is that you can have different compositions of these hybrid teams. So it might not just be one AI and one human, you might have multiple AIs and multiple humans, and how do they all interact and intersect? And that is really quite a complex problem. If you're talking about something like a commercial game for enjoyment, then you're back to that problem of thinking about, well, what really is the role of the game? So if you've got a lot of AIs teaming up against the human, then the human can be, really challenged and really in a position where they don't have much control and they're not able to win. So those are kind of different scenarios, I suppose.
Great, thank you. There's a question here from Ewan, two questions from Ewan, one more serious and one a lighter one. The first one is, what suggestions would you have for someone looking to get started in the game development industry? And the more lighter question is, what's your favorite game and why?
Cool. So, yeah, getting into the games industry, my advice is always to get some experience. So, I mean, it's one of those jobs where even the entry-level positions want you to have some experience, but it's not hard to do. You just need to get your hands dirty. You need to get some of the tools. You need to try it out. You need to work out what you like. You might like to just create some levels for the games that you like to play. You might like to deep dive and play around with some of the AI algorithms. You might like to get in and try messing with some of the shaders or getting some graphics programming. Like, having something to show and having some even experience that you've gained by yourself is just the most important thing, really. My favorite game, I don't know. I don't have much time to play games anymore, to be honest. Sometimes I play mobile games a bit, but between the work and the kids, and I'm enjoying a bit more lately playing board games, I think, with the kids, which is not really what you're asking, but it gets me away from the computer, and I'm just stuck so much to the screen that's hard to really bring myself to to recreationally put myself in front of the screen again. But if you want to be a game designer or game developer as well, I thoroughly suggest playing board games, because you really have to understand and think through all of the mechanics and kind of run the game yourself. I also used to it's very nerdy, but I used to DM different types of role-playing games as well. It's just kind of the fun of creating those experiences.
Fantastic. Thank you, Penny. We've got two more questions here. I think we might call it a day after these two questions. So the first one is from Richard. And Richard asks, can there be a scenario where the AI will always produce the best possible move from the start until the end of the game, like in StarCraft? And how do you know that the move is the best possible move?
Well, it depends on the game, I guess. Obviously there are games that have been solved. StarCraft is probably more on the complex side of things, but yeah, I think it depends. I mean, we're hoping to create scenarios where that's not true, because it's certainly not what's reflected in real life. And the more incomplete information that you have, the less likely it is that that's going to be a realistic scenario.
Great, thank you. Now, the next question is from Leon. And their question is an interesting one. They're asking you if you know how much of computer science research in Australia is funded by the military, and are there any fields that are more or less funded by the military? I assume Leon means within computer science.
I think it's starting to increase, actually, and I think you'd find that the military is increasingly taking an interest in machine learning and AI, obviously cybersecurity and those sorts of things. I don't have a good overview of it, though. Just what I've seen sort of come up in calls for funding. But we try to be very open about it and very sort of careful about how we approach it and think about it.
Great. Thanks so much. We're right on the hour, so I'm going to call. There are still questions backing up, but so it's really great to see such engagement with your talk, and I just want to thank you again for a really engaging and interesting talk, and thank the students who are online for their questions. So thanks very much, Penny.
No worries. Thanks for having me along, and yeah, thanks for all your questions.